So this man sent me a whole load of pictures a little while ago and asked my advice about venting his room in his garden. You know, as we know, there's lots of people building rooms in gardens and things like that today, and there's all sorts of different problems and different ways of doing it, etc. I helped this gentleman and he sent me through some pictures of how he's got on. So if we go back to when I first got involved with this is how far he'd got, and he'd realised that he hadn't allowed any ventilation through the sides or anything if he was going to insulate and turn this into a proper cold roof. So obviously he got in touch with me and we talked through a few different scenarios. So this is the structure he had, which is complicated to vent if you don't do something like this. This is something that recently came through to me. It's not quite right, and this is why the picture came through to me. And the reason it's not quite right, if you see just here and a few other places, the insulation hasn't been fitted very well. Down the side it hasn't been fitted well, but let's assume that down below they foam it all up and they get it as tight as they can, and the insulation as thermally correct as they can get the insulation, and they put a vapor barrier underneath this. Well, now just by adding what we call cross ventilation, they've enabled a good matrix for movement of air. This gentleman on this particular roof, or lady it could be, they could put a vent full length down here, which we call an embutment vent. You could have a soffit vent down here, which means that any air coming in could come in there, run across at an angle, come out over there, vice versa. In fact, they even do the same on the sides. They could vent all four sides if they wanted to. That would be absolutely amazing, the amount of ventilation, all because they had the foresight of putting a 50mm by 25mm batten crossing over in the opposite direction. Now they could even just put maybe 1, 2, 3, 4, 5, 6 or 7 mushroom vents in this if they wanted to, because the air would be able to come in for a mushroom vent, come out of that vent or this vent or that vent. So many things they could have done. We go back to this gentleman here. It would have been very easy to put the cross battens on here so that he could have added some ventilation in. And of course, you know, this is where we started the story, but let's just show you how he got on and how well things have progressed for him. And you've got to remember with this is that this is a garden shed, which is going to be used. I mean, you'll see the pictures afterwards. He turns it into something very, very nice. And we don't actually have to abide by any specifications, but what we're trying to do is make sure that it works and works well. We move over to what he's actually done with the walls, which is very good as well. We've got breeze block walls, and he's lined it all with a breathable membrane and battened it out. Then he's gone over the top of this with some cladding. Now the great thing about this kind of cladding is that it's what we call air open. The wind will go through all the different cracks and everything in here, which means that internally any moisture that wants to get out will go through the insulation and come through the wall and be able to be blown out. He doesn't need to have a vent on the top and the vent on the bottom on the walls here, and the walls will be able to breathe. Now you can see here he's actually put some venting around the top, all the way around the top, and this is part of what we talked about, and he's done an excellent job here of how to get ventilation into the top of the roof, because he didn't put the cross venting in and he didn't think about it. Internally we can see you've got some really nice holes, and if we look here, he's actually drilled some holes through the beams as well to get cross movement. Now you've got to be careful with doing that, because structurally you can weaken this, but remember this is an outbuilding, and as long as it is, there's nobody looking over his shoulder, no building control or anything like that. If you're going to do that kind of thing, you've got to make sure that you're not weakening the joists, even on an outbuilding, but especially if it's on a dwelling, and you've got building control and things like that. Too many holes in the wrong places can cause problems, so be aware of that. Now what he's done here is to put a fitting in which looks upwards, because his insulation is all going to be at the lower level along here, and the top area is going to be the vented area. Now note that he's put all his insulation in the walls, and note that he's using rock wool. Rock wool's fantastic, doesn't burn, gives pretty good insulation, not as good as some of the solid stuff, but there's something I'll talk about in a second with the rock wool, which is really, really good. Now we look here, he's now getting the insulation up into the void between the roofs. You can see the cross ventilation going that way, which would have been so much better if he'd have had the 2B1 battens. For the sake of 25mm, this could have been so much better. But hey, we are where we are, and this is starting to look nice and tight on the way of the insulation. Now, the interesting thing is about the Rockwool is that, again, it's what we call vapor open. The moisture can move through the Rockwool, and one of the great things about that, Sega talk about this a lot. Now, Sega is an excellent company. They do some excellent vapor barriers and systems for cladding walls and roofs and things like that, but they talk about the breathability of the insulation. When we put in some of these solid insulations into walls and into roofs and into walls, the problem is that the moisture that may go past the vapor barrier into the roof or into the wall will not go through the insulation, because the insulation itself is has very good vapor resistance. So it's all that moisture is pushed to the edges, which means that you're taking all the moisture from the whole area and pushing it to smaller areas, which is the framework around the outside. And if there's too much moisture in it, the moisture content of all your wood goes up, and then you can get rotting there. The good thing about having an open insulation, a vapor open insulation like this, is that any moisture that is going through the whole area, not just around the edges where it's got weak points. And when I go out and I see failure in roofs, I normally do see it around the edges, and that's because a lot of this solid insulation isn't fitted correctly, and the moisture is trying to go through the weakest points. So we come over to this one here. Things are progressing along. Now, just with Sega do tapes to seal up their vapor barriers. If you look at what's going on with this particular vapor barrier this gentleman's putting on, if you look at the top here, he's using some specialist tapes, not just silver tapes, but there's specialist tapes as well that he's putting in here to join all this together. It's going to be airtight as well as have a vapor resistance. Now, the only criticism I'd say with what's going on here is that I hope he's used the correct vapor barrier, because I see lots and lots and lots of people using these green vapor barriers, but there's so many of them on the market, and some of them are just not up to the correct standards. And I'll go into that in a second, which ones are the correct ones. But let's just finish off on what's going on here. So the attention to detail on how you tape and join everything up. I always like to say to people, once you put your vapor barrier in, think about if you were to let off a smoke bomb in the room and you go outside, can you see that smoke getting out? Even if you pressurize the room, pressurize it with some air, an air blower at a window, push it in, see if you can squeeze out any of that smoke. And where that smoke's coming out is where you possibly have a problem. It's just a way of focusing the mind on what's going on. Plasterboard going on over the top of everything, and this is pretty much his finished room inside, which looks absolutely great. So this has worked out great for him. But let's go along now and look at what's going on with these vapor barriers, because the key to this is vapor barriers. And just bear in mind that there's a different, if you are going to do things to building control standards, which this isn't, so it can do really what he wants to do, however you want it to last. And of course, if you look at this, that any moisture that does get through his vapor barrier then gets to a wall which is vapor open right away through the breeze block and to the outside. So he's got a great double whammy here. This is a fantastic build that he's done here. But let's go and have a look at some of these vapor barriers. If I just choose a particular, there's nothing, I buy stuff from these people. There's nothing wrong with this site. There's millions of vapor barriers out there. They're all good if they're used correctly, and it's all a matter of used correctly. Now, if you look at this, there's quite a lot here. What's that? It's about 150 square meters for £76. But the problem with this one, which you'll see in a second, is that it might say vapor barrier on it, but is it correct for using on a wall or a ceiling? Now, some of these are they're different classes. We have class 1, class 2 and 3, and class 4 and 5. Now, class 1, which just so happens this one is only for industrial use, and it's vapor resistance is very, very low. We move on to this one, which is 100 gauge, where if I just go back to the other one, we're talking about the thickness of it now. This is 50 gauge. We go over to this one, which goes up from 70 odd quid to nearly double, and it's 1000 gauge. And again, although this is good for walls, it's just not good enough for roofs. For ceilings, if you want to keep to the correct class, which is class 2 and class 3 for standard dwellings. Class 4 and 5 is for things like hospitals, computer rooms, swimming pools, places like that where you've got high or could have high museums, high people content, which means you end up with a lot more moisture. Now, both of these systems come with these special tapes which have to be used with it. And one of the things I like about the Sega system, although I've never used it because I don't do many, in fact I hardly do any cold roofs. But one of the great things about the Sega system is that they test their tapes to last the lifespan of a building, and they actually guarantee their tapes for that. Please don't quote me on that. I remember reading it or seeing it somewhere. You must look it up. So all this information I'm giving you here is just the stuff that I have to find out before I can specify for any of my customers what I'm actually using. So if we move on from there, I was just doing a little bit of research. This Foiltech insulation looks really good. Don't know them, haven't used it, anything like that, but a relatively good price. And when we start looking at the different vapor resistance on it, this particular one is for walls, and it says that it's 600 MSGs, which stands for meganewtons per second per gram. But let's just call it 600 because we're going to go through a lot of figures here, and it's easier just to work on it. They're all basically the same measurement, and I've picked particular materials here on the internet which are all giving information which has got the same measurement, because they use different ways of measuring it, which means that you then have to go through conversions, and it's a nightmare for anybody out there picking a vapor barrier. So 600 would bring us into a class above a class 2 or class 3. It'd nearly bring us into a class 4 standard, which is absolutely great for a wall. And then when we move over, they do another one which is for a roof. I've got it up here, and look at this, it's 1569, which is like amazing, because the standard for the roof is over 580, I think it is, something like that. So this would fall into a class 4 or class 5 in the way of performance to do with building control. Now, look, let's go over and have a look at the Novia website, because I've looked at some of their stuff on here for you. And again, the thing here is it must be used with the components of the system. If you're not using it with the components of the system and the different tapes, the butyl tape that they use, which is this one here, is really, really fantastic. We'll move over to this is the 500 thickness of the Novia. Now, if we look at the specification here, it says it's above 250. Well, above 250 doesn't even cut the cookie for a commercial building. What is above 250? Well, you've got to be at to get to class 2 or 3, you've got to be above 530. So class 1, which is commercial, is 266 for walls. So this could be 255, so it's very misleading in what that says, but nevertheless, that's the 500. We move up to the 1000, which is this one here, 1000, and we start looking at what's going on with the 1000. It says it's above 500. Well, above 500 is great. That's okay for a wall in a domestic building, but it's not okay for a roof in a domestic building. And again, 500 is nearly there, because 530 is for class 2 or class 3. But this could be 510. But listen, I'm being really pedantic here, because it's all a matter of making sure that when it is fitted and we use the tapes and everything, that it's airtight. My last video was talking about airtightness, and it's irrelevant what vapor barrier you use if you're not airtight. If you're not airtight, you're getting more and more and more moisture going through the gaps than what would ever be solved by the vapor barrier. And if we look at this, which, you know, this Nova, say, I'm not condemning any of these products, they're all great, and Novia have got a excellent sort of diagram of how we should be putting all the different tapes together and bonding it all together, and where all the screw points are. But, you know, I find that in practice most people don't. If we go back to this gentleman here, most people just put this up, they don't seal any of the joints, and therefore they have moisture movement in places where they don't want it. Thermal bridging and sweating, and, you know, it's attention to detail. And I assume that when people are pricing, or builders and that are pricing jobs, you know, they're pricing it as low as they can. They don't realise the time and costs of the good quality materials and everything else that needs to be put into putting the vapor barriers in, and putting the vapor barriers in correctly. So we go back to this gentleman's roof here, and exactly what he's done. That's excellent there, and this is really excellent here for the vapor permeability of the whole building. And then when we get back to this and what he's done here, absolutely fantastic. I'm really pleased for him, and he did say to me in an email when he sent me all these photographs that, you know, he feels really comfortable with it now, and, you know, he's been through a winter and he's got no problems. So that's really good news. Hopefully this video helps you. Speak soon.